What's poppin', dogs? Mr. Allen here with some geometry review from semester 2 here, specifically for my GeoCon class, but can apply to really any geometry class, and the lights are off, whatever. We're going to get tricky with it here on this one. Let's start. So you stand 50 feet from a building and you observe a 32-degree angle to the top of that building. If your eyes are 5 feet above the ground when you observe this angle, how tall is that building? Let's go ahead and draw a little picture. Yes, we got a dude sitting over here. Whee! Right? Stick figure. Right? We have this building. Oh my goodness. They observe an angle to the top, but they are 5 feet above the ground. So we can set up a right triangle here with a 32-degree angle of elevation. The eyes are 5 feet above the ground. So that's this part right here, 5 feet, which can also correlate to this spot right here, which would be 5 feet. All right, that's a terrible little teacher bracket, and I'm just going to put 5 feet. 5 feet, okay, cool. Now, we are 50 feet, right? 50 feet from it, so 50 feet right here. Cool, so we have ourselves a right triangle. I want to know how tall the building is, right? So this is going to be an X right here. So I'm going to solve this right triangle. Right now, I want my opposite side. I have my adjacent side to that angle, right? So we can set up with tangent to solve this one. So we got tangent of 32 degrees is equal to my opposite over my adjacent, which is 50 feet. I'll multiply by 50 on both sides, and I'm going to get myself 50 times tangent of 32. Let's plug that in our TI. Make sure you are in the correct mode, all right, when you do this thing, because otherwise it's going to go bad, man. You know, you're going to get some weird answer because you're in radians. You don't even know what radians are right now, so we don't want to deal with that, all right? We get 31.24. That's what X is. So X equals 31.24 and change. But what's the height of the building? I got to add 5 to that. So we're going to get 36.24 feet. That would be my final answer here, right? I'm going to add 5 plus 5. Cool. Next one, how far should a 20-foot ladder be placed in the base of the building to make sure it forms a 76-degree angle with the ground? So the ladder is 20 feet. So let's see here. We got ourselves a building again. We got a ladder, which is 20 feet. We got the ground there, which would hopefully be perpendicular to that building. Yes, nice right angle. We want it to be plumb, yo. All right, we know this is 76 degrees, and I want how far away it's supposed to be. So what sides do I have? What do I want? Where are we at with this thing? Well, I have my hypotenuse. I want my adjacent, right? This is the adjacent side next to this angle. So which trig function uses adjacent and hypotenuse? Well, the adjacent and hypotenuse would be cosine. So I'm going to have cosine of 76 equals my adjacent, which is X, over my hypotenuse, which is 20. So multiply by 20 on both sides. I can just type this bad boy in once again. This is nice. Easy algebra so far on these. I'm sure they'll get a little bit more complicated as we go, but not too bad so far. Boom, 76, close them, hit enter, 4.838, so 4.84 feet. 4.84 feet. Now we know, right? You mathed it up, popped it in that TI, you're like, I'm going to set that ladder just perfectly. Dope. Okay. Number 3 here. What is the degree pitch of a 1512 roof? How could this degree measure be helpful in the context of our construction class? And part 2, if a roof has a pitch of 14 degrees, what's its pitch in the context of construction? So pitch would be your rise over your run, right? So if I have a roof, right, it's this part, 15 is my rise, and 12, just this part is my run. If we got like a gable end roof or something like that. So I can just do tangent inverse of my rise over my run if I want to get this angle right here. That's the angle of the roof, right? 15 is my opposite, and 12 is my adjacent. I know they kind of did that backwards with labeling things, but there we go, and we know we have a right angle there. Again, hopefully, if it's built properly. Which, of course, if it's by us, we're building it properly, bro. So I got second tangent. We got 15 divided by 12. Hit enter, I get 51.34 degrees. So 51.34 degrees. All right. Now, that would be helpful, maybe setting your miter saw, whatever. Not going to worry too much about that right now. We're doing the math stuff. All right. If a roof if a roof has a pitch of 14 degrees, what's its pitch in the context of construction? For this one, you can guess and check, right? It's going to be 112, 212, 312, whatever. But in the event that it's kind of a high angle, like it's going to take a little while to guess through all those, right? We could do tangent of 14 degrees is equal to my unknown rise over my 12, which is my run. That's going to be a standard run for our roof pitches, right? And now I'm just multiplying by 12 on both sides. It's a little hard to see. And I can type in 12 times tangent of 14. That's going to give me my answer. All right, so that's super awesome. So 12, and we got tangent times tangent of 14. You can close out the parentheses. I didn't do it on the last one, I know. Ooh. All right, we get 2.99. So what is that? So 2.99 and change. That's because that 14 is a rounded value, right? So we're getting slightly off. This is going to be a 312 pitch. Okay. It's like our shed roof this year. It's the year 2023, depending on how long I use this video for. All right. If you stand 60 feet from the base of a tree and observe a 57-degree angle, and your eyes are 5.5 feet above the ground, how tall is the tree? If a fence is 95 feet from the base of the tree, can you allow it to fall toward the fence, or should you have a plan to have it fall away from the fence? Okay. So you stand 60 feet from the base of a tree. I'm going to drop a little picture here. So we got a tree. I don't have we're going to go with a purple tree. Okay. Whee! And then we'll go with the green floofy leaves, right? And then you stand, so we're going to say we're standing. Oh boy, that's too big of a marker there. Don't want that. Don't want that. We got to go a little more fine point. Okay. So from here, the center of that tree to here, we'll say is 60 feet. Yeah, that's what it was. All right. And you're chilling there, right? Hi, what's up? Just chilling. Think about cutting down this tree, right? Chainsaw. Woo, it's fun. And you observe a 57-degree angle to the top. Okay. So boom. All right. And your eyes are 5.5 feet above the ground. So you do need to account for that in the height of this whole thing right here, right? I got to add that 5.5 feet to my final answer. And it's a 57-degree angle here. 57 degrees. Cool. So now I can figure out what this value is. X right here, that height of said tree. Okay. Plus 5.5. And then we'll see how far it's going to fall. Cool. All right, so let's see here. We know our adjacent side. I want my opposite side. That's tangent, dogs. Tangent of 57 is equal to my unknown opposite over my known adjacent. I can just multiply by 60 on both sides. So now I can type that in. So we got 60 times tangent of 57. My goodness, this light. Equals 92, but I got to add that 5 feet, and we end up with 97. Oh, my goodness. You know, I'd be a little bit hesitant, even at 92, to let this thing drop. Be like, yeah, man, we're good. And like have it land 3 feet. That's tough, right? But here we got 97.39. So we have 92 first, 92.39 plus 5 equals 97.39. Nope. Don't want to do that. Nope. It's going to ruin the fence. It's going to ruin the fence. We don't want that. All right, number 5 here. So we have if a ramp is 8 feet tall and the length of the slope part is 21 feet, what is the angle of incline the angle the ramp makes with the ground? So the ramp is 8 feet tall. Let me just draw up a ramp here, all right? The slope part's 21 feet and it's 8 feet tall, okay? And we want to know this angle, the angle that it makes with the ground. Well, what sides do I have? I have the opposite and I have the hypotenuse. So I can just do, well, what uses opposite and hypotenuse? Sine, so sine inverse. Sine inverse, sorry, I think the computer froze up for a second there, of 8 over 21 equals, let's plug it in the calculator, yo. So second sine, and then I'd have 8 divided by 21. It's 22.39, so 22.4, yeah, we can do 39, I don't care. 22.39 degrees. Nice. No big deal. I love solving for angles, man. It's always easy to solve for angles. We're actually going to skip over these couple right here as I decided to take them off the final this year for you guys. So we're going to focus more on the ones that were above there of setting up your triangles and not so much into the roof framing stuff. All right. Other than this type right here as to what is the degree pitch in the context of construction. We did one of these earlier, so why don't you try it, pause the video, and then I'm going to pop up the answer here in just a sec. So if I type in, let's see here, 12 times tangent of 42.5, 42.5, close my parentheses, hit enter, I get 10.9959, so 11-12 pitch. So 11-12 pitch. Cool. All right, next one. We had one of these as well. So again, I'm going to pause this thing here in a sec. What length ladder will you need to reach a window that is 16 feet off the ground? You need to set the ladder at a 75-degree angle with the ground to be safe. So try and set it up, solve it. I'm going to hit pause for a sec here, and then you can hit play when you're ready. Pause. So here's my setup for this one, right? I got 16 as my opposite side. That's the height where the window would be. And I want to know the length of the ladder, so that's my hypotenuse. This time I actually got to do a little bit more complicated solving here. I got to multiply by x first on both sides. So if x times sine of 75 equals 16, and then I'm going to divide by that sine of 75 on both sides. Sine 75. Beautiful. So in my calculator, I'll be doing 16 divided by sine of 75 to get that length. So let's type that bad boy in. 16 divided by sine of 75. Boom, close those bad boys. Hit enter. We got 16.56. So 16.56 foot ladder that we're going to need to get to that window there at a 75-degree angle. Dope. Beautiful. Awesome. Next one here, we have the city is looking to make sure that one of their handicap accessibility ramps meets code. The city says the degree incline cannot exceed 4.5 degrees if the height of the ramp is 3 feet, the length, and the slope part of the ramp is 40 feet. Does this ramp meet code, or do they have to fix it? Let's make a beautiful triangle. So 3 feet, the slope part is 40 feet. I want this angle right here. So I have my opposite, OPP. Yeah, you know me. We got the hypotenuse. So what trig function am I going to use with opposite and hypotenuse? That is sine. And since I'm solving for the angle, I'm going to use inverse trig, right? So I got sine inverse of that 3 over 40. So second sine 3 divided by 40. Hit enter. I didn't close them, whatever. We got 4.3 degrees. 4.3 degrees. So are we good? We're good. We good. We good. Exclamation point. Okay. Nice. Couple more here, dogs. Couple more, and we are done. So find the length of the indicated side to the nearest tenth. This is straight up trig, right? No real application to it, but still good. Good practice, right? Relative to this angle, I want my adjacent. I have my hypotenuse. All right, so that would be cosine of the angle 24 equals my adjacent, which is x, over my hypotenuse, which is 15. So we're going to multiply by 15. No big deal on the algebra. 15. Then we got cosine of 24. I guess I'll close my parentheses this time. There we go. If you were to do any other math after that, very important. When you're hitting enter, no big deal. So we get 13.7. 13.7 units, whatever. And it says to the nearest tenth, so we'll do 1 decimal place. Next one, find the measure of the indicated angle to the nearest tenth. So for this one, I want that angle with the question mark. This is my opposite side, OPP, yeah, you know me. And that's my hypotenuse, always across from the right angle. So I'm going to just do sine inverse of 16 over 22. A lot of sine inverse on this one, you know? That's not like necessarily like, oh, it's always going to be that. It just happened to be. I mean, tangent inverse is what comes up most in construction, but it just depends on what we're dealing with here, right? Because tangent inverse is our rise over our run to get our angle. That's why it's so common in construction there. But this one is sine inverse. We got 46.658. So 46.7 degrees to the nearest tenth. Dope sauce. All right, last one here of the trig stuff. We have the requirement for a handicap accessibility ramp in the state of Illinois. Just kidding, it's Illinois. Is for every 1 inch of rise, there must be a 15 inches of run. What is the angle of incline for a ramp that meets this requirement? So my rise, that's not a good ramp. There we go, that's a little better. 1 inch for every 15 inches of run. So this is a scaled down version of it. If I want this angle right here, theta, I'm going to do inverse trig with my opposite over my adjacent. Oh my goodness. Rise over run, opposite over adjacent. That's going to be tangent inverse of 1 over 15. Close them. We're going to pop this into the TI, you know what I'm saying? We got second tangent. We got 1 divided by 15. Hit enter after I close my parentheses. 3.814, so 3.8 degrees. That would be the angle of incline or less that would meet that requirement because it cannot exceed it, right? There we go. That's some dope trig. Sorry for skipping over those 3, but hey, man, if you're watching this, like, bro, on it, oh, we're cool on this one, all right? So got you back there. That was something we did a lot in the actual trig unit, but not so much on the final exam here, so that's why I skipped those 3. Other than that, dogs, I hope you have a fantastic day. Good luck on your finals. It's going to be awesome. You're going to crush it. See ya.